An organization trains some models on Azure Machine Learning compute and trains others from local environments used by different teams. Leadership wants one comparison approach that supports programmatic querying, stores the results centrally, and still lets reviewers compare selected runs visually in Azure Machine Learning Studio. Which design is the best fit? Option A, use workspace-backed MLflow tracking. Option B, use Azure Monitor for all experiment comparison. Option C, compare only models after registration. Option D, store final scores in repository Markdown. The correct answer is option A, use workspace-backed MLflow tracking. A team is deciding how to collaborate on notebooks in Azure Machine Learning. They want a model that allows shared notebook content without incorrectly assuming that one user's development machine is a shared team workstation. Which two statements are correct? Select 2. Option A, a notebook must always be run from the same compute instance that originally created the file. Option B, files in the workspace can be used from many compute instances in the same workspace. Option C, a compute instance is intended to be shared by multiple notebook authors at the same time. Option D, only users with owner access can edit notebooks in the workspace. Option E, other users can open a shared notebook and run it on their own compute instance. The correct answers are option B, files in the workspace can be used from many compute instances in the same workspace, and option E, other users can open a shared notebook and run it on their own compute instance. A team is improving a customer support prompt flow stored in GitHub. They created 3 alternative prompts for one LLM node and want to choose the best one using a representative dataset, measurable results, and a fair comparison that isolates the prompt change from unrelated flow changes. What should they do next? Option A, run each prompt once manually and pick the most fluent-looking answer. Option B, submit a batch run for that node's variants with an evaluation method. Option C, change variants on every LLM node and compare the combined outputs. Option D, merge all 3 prompts to main and compare production complaints later. The correct answer is option B, submit a batch run for that node's variants with an evaluation method. A machine learning team wants a working model for early project work that stays interactive at first but does not trap the entire life cycle inside ad hoc notebook execution. They want researchers to explore data and test ideas quickly, then move to managed cloud execution once the approach stabilizes. Which design is the best fit? Option A, keep all training and life cycle work permanently inside one notebook session. Option B, start with endpoint deployment and use the deployed API as the experimentation surface. Option C, register every model candidate before running any exploratory notebook code. Option D, use notebooks for exploration first, then submit command jobs for scalable training. The correct answer is option D, use notebooks for exploration first, then submit command jobs for scalable training. A team deploys a classification model to an Azure Machine Learning managed online endpoint. They want the fastest supported way to start receiving threshold-based notifications for production issues, and they already enabled inference data collection during deployment. What should they do next? Option A, create Azure Monitor dashboards only. Option B, turn on application insights only. Option C, add out-of-box model monitoring. Option D, export endpoint logs each week. The correct answer is option C, add out-of-box model monitoring.